You don't want to do too much future proofing because the future is hard to predict. But a little bit can go a long way. So you could do a modular design. You touched on it there, where maybe you put a layout pads that not only for one package types, for multiple package types, or a package type that could be adapted.
Hello, everyone, and welcome to the Altium On Track podcast. I am your host, Zach Peterson, and today I will be sitting down and talking with Chris Cain, a supply chain consultant and former VP at Keysight working on supply chain and supply chain products. Chris Cain, thank you so much for joining me today.
Thank you. Delighted to be here, Zach.
So as a new guest on the podcast, I think it'd be great to get a little insight into your background. I know you had a long career at Keysight, so I think it'd be interesting to see what it's like to work there and probably whatever else you've done throughout your career.
Sure. To give a little bit of background, probably when I think about my experiences in supply chain is all about getting the right parts at the right quantity, at the right price, at the right place and time. Okay, sounds simple, but of course it's far from that. And a lot of times supply chain professionals, and I've used titles like this, have the word strategic or planning, because a lot of supply chain is about forecasting or trying to forecast the future. And in general, when as a supply chain professional or managing a team of supply chain professionals, as I've done, you actually are right more than half the time. That's doing pretty good, and you feel pretty good about things. Things get more challenging occasionally, like they are in the last couple of years, and we'll talk more about that. And then your probability of success of predicting goes less than half, so less than the probability of chance. And then things become much more challenging. And so that's where you actually start to pull out a lot of tricks and tips, and also start to work a lot more with your design partners, because the choices that are made during design are absolutely critical to both near-term and long-term impacts on supply chain.
Well, we do often talk about de-siloing around here, and Altium Designer and frankly a lot of other tools that are out there in this industry and other industries are all about integration and de-siloing and kind of enabling that design to whoever else collaboration that you've just referenced. Some of the things I think that some designers might be familiar with in terms of, planning for supply chain disruptions or trying to play CYA on supply chain disruptions, maybe looking at alternatives and selecting those ahead of time, looking at things like packaging, footprints, things like this, trying to select those ahead of time, maybe just avoiding the stuff that only has a single source altogether. I mean, are those some of the strategies that are just really basic and there's much more to it once you get to the kind of scale when you're at a company like Keysight?
And there's also matters of scale. That's usually important. The more scale you have, the more opportunity you have of continuing to get the parts that you want to get. But you can also tap into scale for the larger ecosystem of electronics providers. So it pays even as a small individual developer, or even as a hobbyist or somebody that does this for fun, to really tap into the bigger, broader rivers of supply chains. The bigger they are, the more you can tap into, and you probably can fish off of that supply chain and get your needs met, or find maybe more ready alternatives with a bigger supply chain. So it does pay to, as you said, use the tool sets, the information available to try to tap into where the supplies are there both now and in the future. That's the trick.
Well, so when you say tap into the bigger supply chain and feed off of that, what exactly does that mean for the individual developer? Because I think the individual developer or the individual designer, they're going to go on to, DigiKey, Avnet, Mauser, one of those types of places, especially if they're working on a prototype for a client and they really are on the front end doing that portion of the design. That's most likely where they're going to order from first. But if they're working in sort of a long-term capacity, kind of like I do with a couple of clients, and you need to help plan to get them to scale, what do you do? I mean, I've been able to go direct to vendors for some of the critical parts and set up that relationship with the client, and they're able to get those 10,000, 20,000 units at a time when they
Mm.
need them. But what are some of those other ways to be able to tap into that much larger section of the supply chain that I think is kind of hidden from the individual designer?
That's a good question. It pays to where you have the opportunity. Of course, an individual designer, even one at a large company, doesn't have time to do this on every single part. But there's a lot of judgment involved in it, and usually designers have a good idea of the parts that are going to be more critical. They're the ones that are the more complex parts, the ones that are typically consumed in lower volume just in general. But what you want to do is to maybe not only pursue the parts that are in common high use, but also find variants of those. Sometimes you can go with a slightly bigger spec or lower spec, okay, and find that there may be a big jump in quantity consumed in the world. And if you actually make that shift in your design, you may find yourself tied to a much bigger supply chain that maybe there are alternatives available. Whereas some of those smaller quantity parts, they may be very similar. They may be slightly less speed, slightly different temperature range, or different operational parameters. But if the volumes get low, especially now where there's such constrained supply, a lot of the vendors make choices every day about what they make next, and they're more likely to make more parts they're going to make more money on, which is going to be a combination of both margin on the parts and also volume. And so if you get caught on some of these lower volume parts, even though there may be one quite similar, that's where you have some play that you can move with. In fact, I've had designers more recently in the current challenges take a look at their designs and maybe find one with a slightly different temperature range, slightly lower. They picked one that had a very wide range, let's say over 120 degrees C at the top end, but it's for a design that's used in a product that maybe you only need a top end of 100. And then that exposes a whole different supply chain set of parts. So that's where it helps us to be a little bit flexible on some of the requirements that may or may not be critical to your design, but may give you a big jump in capability. And then there are parts that are very scalable, like memory parts and FPGAs and whatnot. And there can be huge differences in the supply availability, either because of the volume currently consumed or the age of the part. Okay, so you want to be careful to also look out for parts that, especially now, may be at the end of their life, and that's a little hard for designers to see, but that's where some of these experts and some of these communities and some of these tools can give you some insight, saying, "Ooh, let's be a little bit careful. They've announced that they may not make that part in 2 or 3 years," and so you may want to factor that into your decisions.
Well, I'll tell you, I have regularly gone for the over design route when the desired
Mm-hmm.
part is out of stock. That one MOSFET
Mm-hmm.
that was chosen, you just pick the next part number up and it has an extra 10 amp current rating or whatever. And it's like, yeah, it's fine, go with it. Um,
Exactly.
I'm, I think, however, if you're talking about like a large processor or some specialty integrated circuits, then you have a cost issue, right? You don't want to move your price point too much
Mm-hmm.
by doing that, because if it's a resistor, right, it's pennies. If it's a MOSFET, it's maybe a handful of pennies, but it's still pennies, right?
It
But
could
if
be
it's
double-digit percentage of your overall BOM cost, and then that's substantial. That's
sure,
substantial.
sure. Yeah, so like I'll just give you an example I've dealt with, right? Network processors, right? You go
Mm-hmm.
from, one part number to just the next one up or the next variant up. I mean, that could be $20 a unit that you then have to
Mm-hmm.
add into your BOM. And of course, that gets passed on to the end customer. And, if it's $1,000 end product, an extra
Mm-hmm.
$20 isn't going to make a big difference. But if it's, a $50 end product, now that extra $20 makes a real difference.
And you're exactly right, Zach. And there are tools there that designers can use. For example, you could do a modular approach. So instead of designing for a specific microprocessor part or component, you might actually design for a module. Okay, that may be more expensive because you'll have extra connectors and there'll be Z-axis things you'll have to deal with. But that may buy you into some flexibility, because if that's in a standard interface like a COM module, then you could pick. Now, again, there are supply chains for the programming of these things. Those aren't cheap either, and those have to be considered. But at least you can make a switch without maybe having to even relay out the hardware on your board. And so thinking about those alternatives and playing through those scenarios are a key thing for those key components. I've had designers, especially when you think about a design that may last In some cases, for test and measurement products that I've led, they may last 10 or 20 years, unusual lifetimes. You see that in aerospace, defense, healthcare products. And in that case, it may pay to actually lay in a little bit. You don't want to do too much future proofing because the future is hard to predict. But a little bit can go a long way. So you could do a modular design. You touched on it there, where maybe you put a layout pads that not only for one package types, for multiple package types, or a package type that could be adapted. I know I had teams that were making a lot of adapter package assemblies, so they could adapt like a MOSFET from one package style to another. So because you couldn't find a drop-in replacement in terms of the form of the part, but you could find a drop-in replacement for the functionality of the part. And so in that case, for memory, for CPUs, for other components, it may make sense to maybe architect those in a modular fashion, looking ahead to give yourself some flexibility.
Yeah, so I guess the takeaway from what you've just said is once you get to the type of volume where you may have to cobble together designs with multiple packages, multiple footprints, multiple variants, that's really going to lead and influence a lot of the design issues, not just on the main board, but now you're talking about, okay, we may have to have a variant for module A, B, and C. We may have to have a variant that is going to accommodate or leave enough room for this little adapter that we now need to solder onto the board, and anything in between. Is this the type of thinking that a lot of companies do behind the scenes? Because when you buy a unit off the shelf, even if you're an electronics engineer, you probably don't crack it open and look at it. And even if you did and you saw something, do you have 10 others nearby to actually compare it with? I think at the end of the day, as a user of the product, you just don't care, right? If it works, it works.
That's correct. And actually, one of the things I found, it's interesting, this holds true for software development as much as hardware. We're very reluctant to make a change. Like there was a product line that I had teams that worked on that it was a 30-year-old design, okay? And there were like 60 plus lifetime buy parts, okay? And it was super high risk at that phase. But they were very, very reluctant to relay out the boards. They kept trying to do it by component changes. Limited component changes. Unfortunately, you push that too far, and it's like anything, you push it too far, then it's like, well, that's actually making it 10 to 100 times harder. So once we relaxed, we said, well, actually, customers only care about the entire instrument, not the 20-some printed circuit assemblies that are in this instrument. So what we said the instrument had to be drop-in replacement. That had to function identically, okay? But the PC boards, those could change. Okay, but as long as the instrument functioned. Once we relaxed those design constraints, then it opened some things up, and it turned out it wasn't that hard to relay out all the boards, eliminate all of the lifetime parts, and keep a product going that's been going for over 30 years, which is an amazing run for an electronic product. So sometimes you have to step back and look at things, both at the component, the subassembly, or even the whole product level, and kind of break some assumptions that gives you some design flexibility. Now you could say that's catering to supply chain, but honestly, if you can't get the parts, you can't ship your working design. So it's pretty important to be able to do that. And right now there's a lot of constraints because of the pandemic created a lowering demand, and then getting to the endemic phase, it unleashed everything, and everybody wanted to buy a lot of electronic stuff. And certain industries saw almost an exponential move. I mean, EVs. I mean, there's been a huge shift to EVs now. We all sort of saw it coming, but that shift really exacerbated the supply chain challenges, especially around microprocessors, components that were used in the automotive industry. And that's created this kind of enduring supply chain challenge that I think we're starting to see some signs that it's easing a little bit, but honestly, it's not only going to be with us for a little while, but it's fundamentally changed some things. I was starting to see some vendors that I work with essentially say, we're just not going to make those kind of parts anymore because we can make more money making these other parts. So you have to kind of look ahead a little bit. That's the prediction part of supply chain management and getting that insight of what's coming. And right now it's just been accelerated because people see different opportunities to make money, and they're seizing those quite naturally. But it also means in some cases you'll see the part you've been using for 5, 10 years is suddenly poof. It's got a 3-year lead time. 3-year lead time usually means we're probably not going to make that anymore. So you have to kind of take that into account and then think about, gee, what should I do to work around that? And so there's that strategic thinking, and that's where it helps to work. There's some groups like IPC. There's standards groups, consortiums that they do all the groundwork of kind of looking at the industry and the trade and what they think is coming, and it pays to spend a little bit of time keeping up with them. And so that helps you kind of think about how's that going to impact my decision as a designer, picking the parts, picking the materials.
Sure, sure. You brought up something actually that I've experienced, I feel like, multiple times in the past 18 months, but in one ongoing endeavor in particular, which is all of a sudden the part has 3-year lead time. And the
Yep.
only place you can get it is like from an overseas broker. They have the last, 10,000 currently in existence that aren't used in a product or on a
Mm-hmm.
dev board. And so I'm not
Mm-hmm.
suggesting that you go, get desperate and start desoldering breadboards. But,
Mm-hmm.
when you find yourself in that position, is it common that once a part has like a 3-year lead time, according to, the major distributors, that it's just going to end up going EOL and you better plan ahead now?
I would suggest that. I would have an alternative plan, especially if that 3-year EOL sticks for more than 6 or 8 months. If you don't see that shifting like in the past year, but you see other things getting pulled up, then that's just telling you that what's coming, what's likely coming, and you probably should lay plans to have an alternative somehow. And that may be painful, but a little bit of planning goes a long way because a lot of the work is getting to the decision point. Hey, we've got to make this change, especially if you're talking about something that has a deep tool chain, like a microprocessor. That's one of the most difficult things you usually change in the design because it's not just the part that you're putting on the board and selecting for the printed circuit board assembly design. There's a whole toolkit chain involved with that, a whole other group of firmware and software folks that have got to buy into this change. And so you want to get those efforts on alignment and realignment started early. In fact, I was doing some of that before I recently retired because I saw that happening in certain commodity parts, certain FPGAs, certain microprocessors, and said, we need to be looking at alternatives to make sure that we have some flexibility. Because 3 years is so far ahead, that's just a sign that they're going to keep their energies making something else, which is fine. That's their business. But that also means you don't want to be exposed, and then a year from now with EOL and you're deep in some other project having to get redirected. So a little planning can go a long way because you might be able to work on that on the side and then be ready when the EOL occurs.
I thought I was being crafty when this one part I'm referencing, well, I won't say a
Mm-hmm.
manufacturer name or anything, but
Mm-hmm.
I thought I was being crafty when I bought 200 the last time I was able to get any kind of significant quantity because, of course, the customer is projecting out, hey, we're going to need this for the next 24 months. So,
Mm-hmm.
me saying, okay, well, I can project out that, this number of parts is probably appropriate. Sounds
Mm-hmm.
like I should probably abandon that and just recommend a design change immediately.
Yeah, and I've even done that in cases more recently with just because now you could probably sell those parts and get good money for them.
Oh, absolutely. Well, I mean, you
And
just look at what the overseas brokers are selling them for. They've basically taken the manufacturer price and added a zero to it.
correct. And then you also have to be very careful. There's a lot of non-ethical people out there selling what I call is silk screened sand. So it's there may not even be a part inside. It's just a package. So you have to be super careful. Never pay before you verify. That's the rule right now. So.
Yeah, I mean, for something like a surface mount part, where you have to design a custom fixture even just to test it. I mean, the
Mm-hmm.
hurdle is so great. And from what you just said about, silk screen sand, the risk is so great. I mean, why wouldn't you go shopping elsewhere? I mean, I think I get what you're
Mm-hmm.
saying though about, change is difficult because people get locked into these these particular parts, which then start
Hmm.
having stocking issues or, extremely long lead times, and they
Hmm.
become so resistant to change. And it seems like the high risk path starts to look attractive, even if it is high cost.
Yes, yes, and I've also had cases where they maybe weren't a commodity part, rather unique. Like there are custom things like custom connectors, custom electromechanical relays. There's different components that you really kind of need that capability, but there's not a lot of sourcing available. And in that case, I've gone to extraordinary lengths, not only with the supply chain, but tapping back into the R&D community to actually help the vendors resupply their own supply chain. In fact, there was a case last year where I had a team. We found out that they couldn't source a certain relay. They couldn't get the switching element that was inside of it from their supply chain. We looked at it. We knew somebody else that could supply a similar one. So we actually went in and helped them resupply their own supply chain. So don't be afraid to. Now, again, this is not something that a lot of individuals can do, but there's a lot of creativity that can be put to work. Okay. Uh, we've already talked about design creativity, but there's creativity at multiple levels you can do to find alternative sourcing. And it's amazing when there's a will, there's a way. So a lot of people throw their hands up and there's nothing, the units aren't on paper. And no, there may be units around, but there may be another way to source it with a little creativity. So it helps to kind of approach things from different perspectives. That's where I love getting different cross functional teams together because then they can open up some innovative ideas when you do that. And I've gotten out of more uh, really difficult situations that way than I can almost count at this point. But it really does help to have that multiple functional perspective to be able to look at it and go, well, maybe there's this way to actually do it. So sometimes you can design your way out. Sometimes you can fix the supply chain for the vendor. Sometimes you insource. You take it on yourself. You go, this is so critical. It's never going to be that big. Maybe we should bring this in house. And then you do a business analysis to see if that makes sense. And then if it does, you do it. Um, there's also a lot more money that's available with some of the legislation that's being passed, especially in the United States and also coming on in Europe, where there's more of this funding available for local sourcing. So that's a resource to take advantage of.
Yeah, the funding for local sourcing, though, I do understand, and it sounds like you're even suggesting that maybe some companies try to, I guess, for lack of a better term, get their hands on a little bit of that to help finance some of those endeavors to bring that sourcing
Mm-hmm.
in-house or to a partner. But
Mm-hmm.
I question the lead time on that, meaning, how long does it take that facility to get built, up and running at full capacity, staffed, on and on and on. I mean, sometimes just dealing with municipalities, I mean, even that can be an excessive amount of time. And, by that time, does the problem clear up and you're able to get through your next manufacturing run or get your product even to the next stage where you're going on to the next revision?
Mm-hmm.
You know,
Zach, excellent points, and you're exactly right. So you don't do that for little short-term things. These are bigger strategic things that you know are going to endure for a while. So actually, one of the things I started years ago with a set of teams, we had used a particular vendor's operating system. Okay, it's a very popular choice 20 some years ago, and things changed, and we needed to move to more of an open source. Okay, and there was a lot of resistance to that. Oh, how are we going to take all of our tens or hundreds of existing designs and shift them? And we actually worked on a plan that said, well, we don't necessarily need to do that. We do need to start moving new designs to this, shift a few, and then let age take the others. Okay, so that, it sounds like we put together this 10 or 15-year plan. It really was more of a 10 or 15-year strategy, but the intent was pretty simple. One, we got to get started now and stay focused, and then keep measuring, where do we need to make more investments or less to stay on course. And along the way, we also decided that actually we don't need to be putting our own, microprocessors on printed circuit boards anymore. We should probably be buying that as a sub design. Okay. While that was upfront more expensive, if you looked at the total business cost, it was a lot less money. So that's the other thing I like to advocate is you have to look at it not only in the cost of the design you're working on, What about the designs you will be doing, or all of the designs being done across the business that you're in? And sometimes that leads to a little bit different decision making that actually makes things a little bit easier, and you can get things done. But you're exactly right; those are big scale things that you've got to you can't do every day.
So you talked about something kind of interesting here, and I guess it relates back to, some of the most critical components being
Mm-hmm.
processors, which is moving more towards an open source model. And there's actually an
Mm-hmm.
article that came out just recently. It was in All About Circuits,
Mm-hmm.
but they mentioned that more companies are transitioning their chip architectures to RISC-V to help them
Mm-hmm.
overcome some of these supply chain issues. And I think the
Mm-hmm.
issue being that they want to get away from vendors, or first of all, from having to license like ARM, let's say,
Mm-hmm.
um,
Mm-hmm.
and then they can take a little more ownership over that design and get away from a vendor that is already having stocking issues. So,
Mm-hmm.
another ARM component from them is just another issue to deal with. Maybe they can take that over and, contract that out to a foundry. Um, is that a common approach, or is that something that's really just becoming a new thing now that, RISC-V has really started to grow in popularity?
Yeah, I think it's been around for a while in previous generations of processors, but it's more popular now because people, as the ecosystem has become very complex, microprocessors is probably one of the most complex ecosystems in electronics. That gives you the opportunity to really you have to ask yourself the question: is that choice of microprocessor and its development toolkit, is that really core to me delivering value in my design? I mean, it's I need it, but is it how I'm delivering my core value differentiation, or is it a capability I can make a lot of choices on? Okay, and if it's a context, and if it's a context, then you might see, gee, can I outsource that more less expensively, than having all that expertise in house? So can I use an existing design and buy the module? Can I actually pay somebody who does this day and night as a service provider and subcontract it out to them? Those are all valid strategies. They'll have trade-offs, but you first have to ask the question: is that choice of component, is that actually crucial for me to deliver the value I'm trying to create with the end product that I'm doing? And then that should focus you on how much you invest in that decision and whether you should outsource it or how much. And but I think in terms of things like that, memory's been another thing in FPGAs. Having that flexibility, especially as we get reminded now with supply chain challenges, becomes invaluable. We saw instances of that, like with the tsunami in Japan in 2011, the flooding less so in Thailand. That impacted mostly the hard disk drive industry because those were being assembled in Thailand. But when you have a regional impact, you lose some part of the supply chain, and everybody grimaces. This one's big because the whole supply chain flexed, and it's still working to respond, and it's taking years to get into it and to get out of it. But it's also reminded us that there's a cost to this, and how much do we want to invest to deal with that additional cost, that opportunity. So you have to step back and make those choices, both as a designer, but at a bigger level too. And how much do you want to invest in those tool chains? And so I think those are great discussions and thoughts to have. And then whichever choice you make, great, go with it, and then revisit it once in a while as things change.
I like what you said about, is the portion of the design, let's say, that is
Mm-hmm.
having the supply chain issue actually the core value creator in your product?
Right.
And I think this goes back to the issue with people getting stuck on a particular design. And
Mm-hmm.
there's a perception there that it's just going to be too costly, it's going to take too long, reason A, B, and C, that we don't make a change. Or there's a
Mm-hmm.
perceived capability there that this is the only way to create the experience, let's say, that my user cares about.
Mm-hmm.
And so, in order to get away with, or to get away from that, um, it sounds to me like companies just need to explore other options early
Yeah.
and just expect that the thing that you're locked into, number one, probably isn't the core value creator. So you need to
Mm-hmm.
assess that first of all. And second, if it isn't the core value creation mechanism, there are other things that you can do
Hmm.
that can replace that capability, and you still get the same product.
Exactly. Or actually, you might get a better product because your designers have focused more of their talent and attention on creating that more of that core value. So that's what I love about thinking about supply chain. I view it as a way to maximize the return on my investments. And some of the biggest investments any business will have is it's in its designers and its software developers. You want to make sure that they're maximized. I mean, do they really need to be spending time on an AC power supply section? Maybe they should go with an outside, a wall. I call them a wall wart, okay, but an AC to DC brick. That simplifies a lot of designs and a lot of testing requirements because you're not bringing AC into the product anymore. Okay. Now there's trade-offs with that as well understood, but I found sometimes if you break that mold, then it's like, well, that's just less work we have to spend in that area. Then we can spend the work in some other area and create more value. So I love the thought of using supply chain or tools or anything, processes to create more value. That's what I always love about engineering. In the 37 years I've had so far, I love creating things.
Well, you brought up 37 years. I'll be 37 in 7 months. So you have definitely significantly more experience than I do. So I respect the experience. And given your experience, I think it's always interesting to compare what's going on today
Mm-hmm.
with some of those challenges in the past, because anyone who has
Yeah.
worked in this industry long enough, I'm sure, has experienced multiple disruptions of some form or another, and possibly multiple geographically isolated disruptions, like the Japanese tsunami, at one
Mm-hmm.
time or another. I'm wondering if you have that perspective on the history of the industry and the supply chain as a whole. Um, what's the mindset for navigating these types of disruptions when you have a COVID, or when you have like a China, zero COVID policy, and you never
Mm-hmm.
know when some big group of factories in China is going to get shut down and quarantined for a month.
Yeah, and so you have to kind of take that and, to be honest, a lot of people talk about supply chain resiliency at this point. And resiliency, actually, if you look 2 years ago, resiliency was about making sure your workforce stayed healthy, could actually work together in a COVID spread environment. There was a lot of talk about that. That's kind of passed a little bit, except in places, as you said, in China. And so now you're seeing a wave of electronics manufacturing, both at the IC level and the assembly level, shifting to places like Vietnam, Thailand, Malaysia, the Philippines. Okay, a lot of that existed before, but now it's just been bumped up a couple of notches because they need to lower their risk. And it pays even as a small scale designer to pay attention to that because those could present an opportunity for you to take advantage of that new lower cost, more resilient, more flexible supply chain. Like the legislation that just came out in the US, that's going to change investments. Right now, 4% of the printed circuit boards are built in the US. The rest are built elsewhere, mostly, of course, in Asia and in China. But I think that's going to start shifting, mainly not because of the legislation, but the cost of logistics, the cost of oil. Okay, moving stuff across the ocean, both time and the amount of fuel required to move it, that's expensive. That's going to really drive, I think, more of the localization. We've been seeing that for years. There's a lot of electronics manufactured in Mexico now. Okay, so again, it pays to look at kind of these big mega forces and then just be ready to take advantage of them when they start to play out. And as you said, the ones we can't predict are the pandemics, the tsunamis. Those happen. We couldn't predict them, but you can predict what will happen from them. Okay, and from the tsunami, there were a lot of very unique supply chains in Japan that were disrupted, and a lot of people said we need to set up at least a backup somewhere. Okay. Still love the Japanese supply chain that came back relatively quickly, but it pays to have a backup supply chain somewhere. That requires some investment. And so I think we're starting to see that with COVID. And we just talked about some instances where some parts have 3 year lead times. Probably ought to be starting to think about maybe I'll never see that part again. and I need to think about what my alternatives are. And so I think that's a good thing to do at this point. This latest impact in supply chain is about as I've never seen it as widespread. I mean, it was global in nature. It impacted every place, and not just a one-time event, just kind of a rolling wave. And now what I'm seeing is that the bigger impacts are less about, just getting the next set of parts. Some of the things are freeing up, but as I said, now choices are being made. Maybe we won't make that line of microprocessors. Okay, we were going to consider end of life on that memory in 5 years anyway. Let's just do it now. Okay, and so those decisions are being made. You want to be careful and try to get in tune with those as quickly as you can, because that has a big impact on the design you're working on now, or probably a big impact on the designs you've already released, and you may have to go redo.
Well, in terms of what maybe companies need to do going forward in the current environment,
Mm-hmm.
um, you brought up some good points about what's going on with logistics and fuel costs and all this. And I know, fuel costs kind of push up the cost of everything else. It's
Mm-hmm.
related to an, it's essentially an inflation driver.
Mm-hmm.
And so if you look at the cost of labor overseas and then you look at the fuel costs and the time involved, of course, time to market always being critical.
Mm-hmm.
Yes, I agree with you. Geographic diversification makes sense, and it makes sense to spread some of that new capacity back home so
Mm-hmm.
that you can access it easily and you're not subject to global level disruptions to the same extent that we were in 2019, 2020.
Mm-hmm.
um, Now, cost is an important part here,
Mm-hmm.
but there was just a report released from the ECIA, so the Electronic Components Industry Association, and they pointed out that their sales index has started to go over a cliff, so to speak. That
Mm-hmm.
terminology wasn't used, but when you look at their index and the
Mm-hmm.
decrease over a 1 month period, it kind of looks like that. And
Mm-hmm.
then the EDDI report from Spectra, which is one of the divisions of Altium, shows pretty much the same thing in terms of sourcing activity and inventories.
Mm-hmm.
So, given that that is coming up in the short term, and then demand still being high because we still
Mm-hmm.
have stuff that is like impossible to procure, or you still have to go overseas for it, and
Mm-hmm.
then given the fact that new capacity doesn't come online in a matter of months, it is
Right.
typically a matter of at least, I mean, bare minimum, a year.
Mm-hmm.
What do people do between now and then? Because I think people are rightfully maybe hesitant to go overseas as their first choice.
Mm-hmm.
There are brokers I've worked with overseas, and I've never gotten anything bad from them. So, my wooden desk, I'm
Mm-hmm.
knocking on it right now, just hoping that that never happens.
Mm-hmm.
But what else can we do outside of some of the strategies that you've mentioned, which appear to be more like at the design level, working with variants and considering having multiple variants of a design on the front end? Should design firms and design teams at large companies maybe consider just building that into their budgets
Mm-hmm.
immediately? And if you're like at a small design firm, you quote that for a client and you just say, hey, listen, we've got these 5 at-risk parts. I'm going to
Mm-hmm.
give you a variant that has the alternative package on it, and maybe it costs an extra 5 hours or something, but
Mm-hmm.
they're going to be really glad that they spent that extra 5 hours of design time up front and
Mm-hmm.
got that risk taken care of, versus when they try and go to produce something at 500 to 1,000 units and all of a sudden they can't procure those parts.
Yep. Or be ready to do a quick design spin, which fortunately we're enabled by some of the great tools and methodology and everything that's available. So I've learned to count. This has changed over the past 5, 10, 20 years, of course, but I've found it's much easier to spin than we tend to give ourselves credit for. Okay. And PC boards, actually, I'm amazed at how quick you can get a turn. I mean, there are some vendors I've seen, they'll quote less than 24 hours. I mean, depending, of course, on the complexity, but that's not unusual. I've had a number of teams do that for MPI designs. That's very helpful in that case. So bank on that kind of spin flexibility to deal with what is now the unknown. Okay, because so scope, schedule, resources. I was a project manager for a lot of my career, and I still think in that trinity all the time. And so if you can be flexible on scope, okay, then you can adjust a little bit on some of the other things. So I give people, build that into your plans a little bit, and then also I'd go after what I call maximum usage. Look for things that have the biggest flow, okay, because those are the things that will probably keep flowing. So the more you can attach to that flow, okay, the more chances you'll have of continuing to be able to procure a few more parts out of that flow. So if you have some way of finding out what's the biggest flow for that set of components, or are there alternatives, without having to do a huge amount of work, that pays off. And we talked about that a little bit earlier with design variants like temperature coefficients, memory sizes, whatever. Build yourself a little flexibility, and if you could do that architecturally as well, then that's another form, although that tends to be more expensive. So, but I think we're going to continue to see things change, okay? Because but as you said, I think I'm starting to see the same thing. The demand side starting to flex up a little bit. Well, people have had to spend more of their dollars to put fuel in their cars and more food on the table, and there's a fixed amount of dollars, so they maybe put off the next electronics spend. This is at the consumer level, but it tends to float up. So we're starting to see the demand side let go. That will help, again, the parts that have the most usage. Those are the ones that'll become the most available, and their price will drop the most quickly. The other thing is I'd coach people to be a little bit careful about buying the future. I've seen some decisions in the past year where people were buying like 3 years worth of parts, at 10x, 20x levels, and it's like, whoa, I don't think it's going to last that long. And plus, if I'm faced with spending, $5 million, let's say, buying some 3-year supply of parts, as opposed to reinvesting in a turn a year from now to get a variant, maybe I'll pick that path. I'll buy a year's worth, not 3. I'll buy some future, but I think I'd rather depend on my other flexibility, my design flexibility, the overall sourcing flexibility. Like you said, there are a lot of these brokers are working overtime. There's a lot of people putting a lot of effort and money. I'm always amazed at how many parts get squirreled away around the planet. Just amazed. So they're still prying loose a little bit. But more of that will happen, not because they're at brokers, but because somebody bought way more than they needed. So that 3-year supply turned into like a 6-month, I didn't need anything. I needed a tenth of it, let's say. And then they put them back on the market. That should start to free up. Now, will it free up your part? That's always hard to say. But at a macro level, I think we'll start to see some of that. And we'll suddenly see, I think, by the end of this year, not for everything, but a lot of things will start to ease up, especially for the common parts.
I'm starting to wonder also if we'll see a state of revolving surpluses instead of revolving shortages, because right now there's a passive surplus. I mean, you go look up most passives on, DigiKey and Mauser, and yeah, they've got 10 million in stock, no problem,
Mm-hmm. Yeah. So yes, if history is any indication, that's always happened before, and it'll happen again. Memory's gone through that forever, especially dynamic memory, those waves. They've dampened a little bit only because instead of having 6 or 8 suppliers, there's like 3. So, but still, for a lot of other commodities, in terms of parts, that'll happen. Yeah.
So what does that do to the business cycle for different companies or different areas of the industry, right? I mean, how does it affect a parts producer, both in terms of the investments they make, their profitability, how they operate, versus the parts consumer, even a high volume consumer like, for example, Keysight, who has to buy a lot of components and put those into an assembly? Seems like it's going to benefit the consumer because obviously surplus supply, you would expect naturally prices to drop a bit. They're able to increase their margin. For the producer, maybe they have to scale back and they run their fab at, much less than full capacity.
Yes, or maybe that part that they suddenly EOL'd, they'll bring it back because there's demand still there for it. The one we EOL'd 3 months ago, oh, well, we'll make another short run of that and, make that available. So I think some of that will start happening as well. I mean, that's happened before. It'll happen again. Now, will it hit your part? We'll have to wait and see. But yes, they'll spring back. And what that is right now, the power is with the suppliers because they're short on the supplies. So the prices rise. They have all the negotiation position, and then it'll shift back to the buyers. Probably be a little overweight on the buyers, and we'll see a collapse in some areas or an oversupply of parts, and then it'll shift back again. Okay, and it'll dampen out. It's always kind of a classic dampening economic waveform, so to speak.
Yeah, yeah. One other thing I was wondering, and this has, come to mind recently after speaking with Travis Kelly. I'm not sure if you know who he is, but he's CEO of Isola Group.
Mm-hmm.
And he had mentioned that the supply chain for materials, just the raw materials that go into printed circuit assemblies, and I'm sure plenty of other materials we could point out,
Mm-hmm.
is probably even more fragile than the semiconductor supply chain. So
Yeah,
all of the stuff that we've been talking about in terms of components, does it apply equally to raw materials used in assemblies?
it does not. In fact, it actually gets
Okay.
kind of scary. If you look at ICs, like the raw silicon ingots that go
Hmm.
into, they dice them into the wafers and then they build an IC wafer out of that. Um, those raw ingots are made by just a couple of companies.
Hmm.
We're talking about very mature businesses that over time have gone down to a few players. They make fairly good money, but there's not a lot of players left anymore. And then there are geopolitical challenges. We all know that a lot of the rare earths are still mined out of areas in China. And there were some rare earths that came out of the Ukraine.
Hmm.
And the war in Ukraine put a shortage on those. We all know that lithium is, although it's one of the most common elements in the planet, it's not equally distributed, so it's hard to mine out. And so right now there's a massive scramble for lithium for lithium ion batteries. And so yeah, the materials has its own unique flair. And I'm not suggesting a lot of electronic designers get into that too much, but it's probably good, at least at some level, to be aware of that and know where there may be some sensitivity and just be ready to go with the larger flow. Again, maximum usage. Although I'll tell you where there's the biggest demand, there'll also be the biggest investment. So it'll recover probably more quickly than they think. They like to do a lot of doomsaying and say, oh, we won't be able to see this for 3 years. No, we'll probably see it in about 3 to 6 months. It may not recover for a year and a half, but when there's money pushing behind it, that generates the supply pretty quickly, actually. So but again, there it's maximum usage. You want to depend on that. Now, where you've got a very limited, like I remember a product that my teams worked on was actually it was an X-ray inspection system for printed circuit boards, and we designed and built our own X-ray tube, high-powered X-ray tube, and in that tube, it actually had a grid at one element. It was made of hafnium.
Okay.
Hafnium. Look
Yes.
up hafnium. There
It's
weren't
heavy,
many
heavy
people on the
metal.
planet that would mill hafnium
Yeah.
into a grid for an X-ray tube. Very limited supply. In fact, at the time, we had one guy in the LA area. There's an amazing number of little shops in the aerospace defense industry in different areas like LA and whatnot. And one of the things that I did is I said we need to have an alternative, and we found some guy in Eastern Europe and set up a different supply chain. And we actually would we'd alternate the contract so they both stayed in business. And so you have to
Mm.
kind of, for that's an incredibly unique and very precise situation. But take a look at how you're adding value for your customer. If you have anything like that, give that a fair amount of attention. Don't presume it'll last forever. and and,
I
and so it pays to have an alternative, which comes back to so finding that maximum usage stream and having alternatives is pretty key, and then being able to quickly shift to it. That's the resiliency. So if you can build that into your processes, both supply chain and design, you're probably going to be okay.
I have never heard of a buyer splitting contracts between two vendors to keep them both in business because they
Oh
were
yeah.
that critical. I mean, first of all, you know, kudos, because, you know, they're probably both individuals and I'm sure they need it, being that what they do is very unique. But that's actually a really novel approach to ensuring that you have a resilient supply chain that is also geographically distributed. So I guess great job on
Correct.
that.
Yeah. But you don't get a lot of credit for that until all hell breaks loose. Up to that point, people are going, "Why are you wasting time and money doing this? This is more
I was
expensive."
just thinking that. I was just thinking that.
Yes. So it's actually not unlike design decisions that you make. How do you know you're going to need that capability, that much of it? It's a judgment call. Okay. You can do some scenarios, and actually did that in supply chain. And it's easy to do the dark, I call them the dark scenarios, the dark side, the disaster scenarios. But with a single source, if they up and quit, stop, whatever, then you're done. Okay, what's that going to cost you? And you can map that out, and there's a recovery, and you go, well, that's not acceptable. Then you should have an alternative, and compare the cost and ongoing investment to support that alternative as compared to the disaster scenario. Although I would rather say, on the more positive side, like what I did is I did a scenario that said, well, what if our business doubled and I needed to be able to respond? Now I have the ability, I can pass off and increase the contracts to these two different companies or individuals to make this particular component, and boom, I could double production capacity and get an upside. And a lot of times being able to react in a quick time and take advantage of the upside, that's being ready for that kind of business or resiliency, either in supply chain or by your design teams, that can be worth a lot.
Well, these are all great things to think about, and I definitely appreciate you coming on here and discussing all of this with us, because this is the type of stuff that I've mentioned before. I've kind of made it my resolution for 2022 to get deeper into this, and so this has been very helpful for me personally, and of course, I hope the rest of the audience. We're getting up there on time, but I definitely want to say, Chris, thank you so much for joining us. This has been extremely insightful, and hope to have you back in the future, hopefully when supply chains get a little better in their current state.
A little less exciting, yes.
Sure, yeah. Maybe that one won't have as many views.
There we go. Well, thanks, Zach. I really appreciate it, and I hope the audience had some good insights, and always love to hear back from people and learn. That's the main thing. I'll leave you with one last little bit. Always pay to learn. There's always a payback to learning, no matter what job you're doing.
Absolutely. Learning always has positive ROI.
Exactly.
Thank you very much again. And to everyone that's out there listening, we're going to have some great resources in the show notes. Make sure to check that out. Also, make sure if you are watching on YouTube to hit that subscribe button. You'll be informed of all the new updates as they come out. And last but not least, don't stop learning, stay on track, and we'll see you all next time. Thanks, everybody.